presentation. If that was not where you intended to be, you may go and take a look at other things as you want. You can also look ahead on the slides to see what's here to get an idea of what's happening. But then again, I'm also offering this as a very interactive session. Please raise your hand, ask questions, come off mute if you want, be respectful on that. But I'm here to help share what we've done and what we've learned. And if you're looking to learn more on a specific thing, please do not hesitate to ask for your question. You will help facilitate the chat and we'll get going. Okay, who am I? Hi, I'm Shay. I'm technical architect lead with Stanford Web Services. Been with this group for about 9 years now. BC, so I'm north of the border. So that's why my internet sometimes goes a little bit flaky. They tax the bits and bytes at the border and sometimes customs gets in the way. So bear with me on that. Did I freeze again? Am I freezing? You guys froze a little bit. This is working. I'm good.
You're okay, Shay.
I'm going to keep going. Moving. I'm a technical architect lead and senior developer. And what I'm going to talk about today are these two websites or web applications. I say that web services in partnership with a whole bunch of people, and I'll go to that second, launched recently for the SA, Alumni, and OOD, Office of Development groups underneath the ADAPT initiative at Stanford. So this is the My Account and the Alumni Directory web applications. Just a quick overview of what those are. So the My Account is a portal for alumni to manage and edit their personal information, set some settings and sort of their profile, if you will. And the directory is a directory of all of that. So the information being used in both of those things is used in a plethora of other spaces and things, but we'll talk about how we put together these two sites. So as I was saying, this was a lot of people. So I get a chance to talk today, but I wanted to just call out to make sure that everybody knows this was a combined effort between these four groups in particular, but more. So if I'm missing anybody, please let me know. But Business Technology Services, Enterprise Technology, Stanford Web Services, and then the Office of Development and the Alumni Association. So this was again, underneath the ADAPT initiative. So many people in play, many parts to make this whole. Okay, so done with intros and what this is, let's go straight to demos, because that's fun, right? Let's go. I've already been timed out, so let's try this again. So I'm going to introduce you to, and this is the UAT site, so I can modify stuff. You probably haven't seen this because it's behind authentication. So this is one of our 4 SSOs that's on campus. So this is the Stanford Pass architecture as far as things go. So this is built on Oracle IDCS, or the Identity Cloud Systems. And I'm just going to log in with a test account and sign into this. I'll go over the details on all these little things here as well, but I'm going to just introduce the sites, what they do, and then we'll go into how they were implemented. When I do see a couple of things into chat, let's quickly have a look.
Shay, it's just me sharing a link to the presentation.
Great. I'm just going to bring it up and have it. So I've got enough windows. So you guys are up here, demos are down here. I think we're going to be good. Okay. My account settings. So when you log in, so you have to be a part of Stanford Pass, which means you're an alumni or special staff or a person as far as who's allowed to log in. But you've got different settings you can come into here, and these are your tools to control your personal information and how it is used elsewhere across campus. So we're going to talk about the two parts that in particular today with the web applications, and that's the My Account and directory. But again, this data is used in a number of different places. So first thing you may see is we've got an integration with LinkedIn. So one of the requests that we had was we want to make it easy to import your professional history. So that's part of your profile as well. So we do have a LinkedIn import, and we can actually pull that information up. And if you're interested, I can go through that later. But basically, it's a sync from your LinkedIn account. In particular, what's interesting is your privacy and visibility. So very much along modern day best practices to be able to control your information, what you share. So what Stanford knows about you, but also what you share with the world is also up to you. So this really does empower those individuals get in here. So we've got a nice form. And again, you see that loads pretty quick. This thing's all pretty snappy on here. And I'm calling that out because we talk about this later about where we're getting the data from, because this is sitting on a serverless host and is pulling from APIs. So things are rolling pretty snappy here. Got a form. Form's got a bunch of different validations, some nice little transitions. I don't know if you can see that, it kind of fades in, fades out. We've got validation on things. So yes, I can turn everything off if I don't want to. Turn things back on. Lots of different little bits of logic to turn these things on here. So lots of little detail-y stuff on what happens on these forms. So you got a bunch of stuff in here. We also have options for hiding you completely. So a little bit of a bouncy scroll, but you can turn off like all your visibility. So like, I don't want to show up anywhere, so turn me all off. But we're not gonna do that today because it's not gonna be fun for part of my demo later. But very much along the lines of what you would expect. If you made changes, discard changes. So a little bit more away from that kind of website feel and more into that application feel that you're probably used to just about everywhere else you go to these days. And then we get into more of the same. So lots of forms, lots of information, customized digital names, some hidden stuff. So again, lots of stuff in here. We can even dig into some more details. You can upload your photo. We got departments. We got these nice little slide drawers that are in here, and you can say more things. So about pharmacology, you know, majored in basket weaving. Or what? My dad actually always loved to say major in underwater basket weaving. That was important to him. So we'll just say that. So we get a nice little update saying that was great. Okay, thanks, acknowledge it. We can add images. You can drag stuff, or you can do kind of the traditional pick. Let's see. Let's grab this guy. Grab him. You can upload him. I'm going to save that. Okay, thanks. You know, your profile image will show up here, and then you'll get it up in your little banner up there. That's kind of nice. So lots of information. So privacy, visibility, about me. We got, I should have gone to your professional information. So as we go, so we've got experiences, career support. That was an interesting thing, whether or not you're open to offering career support. So that will show up in places in the directory. So if you're looking for somebody and they're willing to support you, then you can find them. You can edit, and what actually I was looking for is these in particular. So I'm in my, this test user has done some things, has had a career, let's just say. There's a few options in here. But what you're seeing in this LinkedIn import, or sorry, in here is these little bits of LinkedIn icons. So this data actually, the original source of it was from LinkedIn. We're not pulling it directly every single time. We actually consume it from LinkedIn, and we add it to our database as well. So we augment it with the data that's there. So that's pretty cool. So that's kind of neat. Okay. So I've got all this stuff over here. I can edit it all and change it. Let's talk about this part. So this is the other site. This is the Alumni directory. So I was actually signed in before, even though my logo was there. So if I just do a little refresh, I'm just gonna just re-log in and refetch everything. I should be able to see that I have a new logo in there. So it's gonna take a second. It's gonna load the search engine. It's there. So I did one little update. So hey, look at that, live demo update right away. So off to a good start. Things aren't breaking. We'll do another thing off we go. But so the directory. So this is the Alumni directory. This is a people search. It is powered by Coveo, which is a SaaS-based search product. You may be familiar with things like Algolia or even like OpenSolar or some of the other, what's the AWS one? I can't remember. They've changed it from their OpenSearch to something else now. But so you can get in here and you can start looking for somebody. I can look for, sorry, Z1 for me, or my test user that's in here. There's a bunch. So I'm not Z1, I'm Zshen, sorry. We can go on. There's me, so you'll notice I've got a little bit of a difference between the logo, but we'll talk about why that's that way right now. This is a dev in UAT, so I actually have to double check to make sure that everything is syncing, but we can look for specific individuals. We can kind of just do a general browsing, and you can also then drill down. So say you're, hi, you know, I met that person. I think they were working in legal services, and they were close to me. So I can go and find, so I'll allow somebody close to me that's in legal services. So I'm up in Squamish, like I said, so Vancouver, very close by. And I was like, oh, it was Jan. I'll go check out Jan Marston, and then I can find out more information about Jan. That's here. If Jan was open to career support, there'd be options to see career support, but I can see what they are offering to share. And so I can see it. When I log in, I have a set of permissions that are available to me depending on the type. Also, Ray, I'm seeing your question. I'll get to that in a second. I'm seeing that I get assigned to a type, and different types of alumni are allowed to see different types of alumni. And that's a terrible way of saying you're graduating the GSB or ed or med or law or something else. You may see a different set of results than the person that may. So my test user has a general set. We kind of get to see everything in this case, but not everybody gets to see everybody. If I go back, you'll see my state is history is preserved. And then there's lots of things I can drill down on: school, area of study, specialty. I can find other things we can search for. There's construction, I guess, is one of my recent ones. We can actually search within the facets that are there, find stuff, all live dynamic fetching.
Hey, Shay.
Yeah.
Sorry, there's a question in chat from Ray, and I'm not sure if you'll be covering this later in your session, but Ray, if you want to ask, or if you want to read it, Shay.
Sure, I got the question here, so I can answer that. So thank you, Ray, for asking, and that's a really good question. I'm going to get into that and some more. But to answer your question, this is a React-based framework. It is NextJS. And no, we didn't use Bootstrap. We use a different CSS library called TailwindCSS. So I hope that answers your question. I'm going to get into that some more as we get into the slides. Just want to introduce what these two applications do and sort of what they what's available to them. They are built on the same foundations, and the same principles are applying to these things. And we can kind of go back and forth, and they connect. So we did that one, we did that one, we got through the demo, I didn't fall apart, things worked, that's good. Whew, we're there, okay. So the question that you asked is pertinent, the stack, and I put an asterisk there because it's a lot of things. We're going to go over all the things because it's a decoupled serverless build. And by decoupled serverless, it means that we have a web application that sits on a CDN that is powered by LAMBDA functions. So there's no like node server or PHP server or Go or Java or anything sort of under the hood. It's CDN, LAMBDA functions, which are small little stateless functions that spin up and spin down as you need them. Everything, all the data that you were seeing, all the information, that's all powered from an API that was built by enterprise technology. And that comes from SnapLogic and MuleSoft. And MuleSoft Gateway, it's behind authentication from Keycloak. Our host is Netlify, so that's our host. So we do run the serverless architecture that they specify. So they take a lot of the load for us. So what happens when we put that website up, it is a Next.js product primarily, but we ship it. And by shipping means it goes into Netlify, it gets built. So we statically generate some assets. But then when I'm accessing the site, because all this is personal information, we are fetching all of this live and in real time from a remote API. And so this is all being requested as I go. So as I log in, so I'm getting information from our SAML service provider, our authentication provider, and then I'm pulling information from a API to fill in all this. So we've got a search engine behind this one, and we've got an API powered behind this one, which is read and write. So I can actually edit things as well. So I can change my name and do things. But you notice this is pretty quick. Like all this information is coming from a remote API, and it's fast. And I'm going to talk to you about how we did that. So the stack, all the things. So what did I go over? So we got Netlify, we've got AWS LAMBDA. Those are our functions. We're using Material UI components for the form elements. Our code is hosted on GitHub. We also use the CI/CD service GitHub Actions. Keycloak is our OAuth service that protects the API that's hosted by MuleSoft. Has a SnapLogic backend, is powered by an Oracle DB. I'm going to go over the architecture in a little bit, so hold on. Don't worry, it's going to be a lot to process, I know. We've got monitoring, that's Status Cake. When we were building development, we used Swagger to mock and to provide a mocking service and a mock API that we test against. So when we run our tests in Circle CI using Cypress or Jest, which I didn't add here, we can test against a mock service rather than the real data. We use Google Analytics for tracking user behavior history and errors. Coveo is our search engine, I was mentioning. We use NextJS as our React framework. We also use Redux and Redux Toolkit with TypeScript. We use PassportJS as our authentication provider, validation service. So it's SAML and JSON web tokens. We use HashiCorp Vault, which is the Vault service at Stanford. So it's vault.stanford.edu to pull secrets and do secret management. We integrate with Gmail to manage emails in the Gmail service. We've got integration with Google Maps and Smarty Streets API to do geolocation and API, IP and localization stuff. We use React hook forms for inline validation for all the elements. And we've got Storyblock as our CMS sort of asset management for this one. So that's hosted the image, has an image manipulation service. Salesforce is sort of the end of the stream for everything where all the data is kept or comes from. And then we've got Tailwind as our CSS utility. We also pair in with LinkedIn and their API to pull data as well. So yeah, it's a lot of stuff. Let's talk a little bit about how those pieces connect. So I'm going to make this a little bigger. So here is a map, sort of a topology of how things are working. We'll start here. Oop. Yeah, I'm going to zoom out. Where's my grabby hand? Which one is that one? Okay, well, we're going to just bounce around a little bit today. These are the two sites. So that's what you saw. When you interacted with the two sites, you entered here. So these are hosted on Netlify. They're hosted on their Netlify Edge, which is their CDN. So they're built and distributed across the globe in, I forget how many points of presence, but their CDN has close to 200 points of presence around the world. When we are fetching data, it all goes through our AWS Lambda functions. These are also provided and managed by Netlify, which is wonderful, but all of our transactions, all of our data goes through a services layer. And it's a microservices layer. We have a microservices design to think. So lots and lots of API endpoints to handle all the data. But I'm talking about build time a little bit first. Like I said, our code is all hosted on GitHub. So for developers, when we're working on things, we still do the regular pull requests and we work in an environment that's very normal to us. We've got our CI and CD tools there to run tests and validations. We have our secrets, all of our keys, API tokens, certificates, all those things are managed in Vault. And they're pulled in on real time when we build and shipped to the platform. So safely shipped out to both the CDN and the Lambda functions that are out there. So serverless means we don't have a server running. It doesn't mean there isn't computers somewhere out there. It just means like there's no database, there's no long-term processor. All of our back end is done through functions and these AWS Lambda functions. So they're out there. CDN is a content delivery network. It is a cloud thing. It's a whole bunch of computers out there in the world that are geographically distributed that will host static assets, meaning they bring it closer to you, which means that your time to receive that is shortened just by the fact that it's physically closer. There's a secondary network that's also going to talk about. It's the edge network, which is also a processing layer that's right there in front of you, as close as you can, but that's there. All right.
Shay,
yeah.
There's a question about what does CDN stand for?
Just got that one. So CDN is the Continuous Delivery Network. So thank you, Ishi. Appreciate that. CI/CD, thank you, Ray.
What does CI/CD mean?
Yeah, Ray's got that one. Continuous integration and continuous deployment. So when I say CI/CD tools, I do mean those things, and it's a lot of the automated task runner type stuff that's there. So thank you, John, for keeping me honest. Thank you, Ray, for helping shape it, and thank you, Ishi, for bubbling up and getting my attention. Appreciate that. What it was about today. What are we doing for time? Well, decent. We're gonna make it today. Okay. As I said, we've got a whole bunch of different integrations. So when the website interacts with remote APIs, we go through our service layer. So all of the things that you interact on your browser, when you're sitting around clicking on events, they are making requests to the microservices layer that we've set up, which then handles the backend transaction. So everything's super secure. We can put a validation and authentication on each of the endpoints, depending on who you are. We can then connect securely to those remote services through API tokens and things. So none of those keys or things are exposed to the browser. And we can sanitize any data that we get back. So we can make sure that we have a layer in between you and the browser as a person and the remote service. So the browser isn't directly talking to these third-party APIs. You're going through our layer first. It's fast, but it allows us to control the data that is being fetched and received and how it's formatted and presented back to the browser. So we connect to a whole bunch of things externally for the My Account service. So we, like I mentioned, we connect to LinkedIn. We've got Stanford Pass that we log in through. There's Gmail API. There's an AWS API. One thing actually it didn't show in here, there's actually an IDCS API as well. Our login is sent through SAML. So SAML, you need two things. You need a service provider and an identity provider. So that basically means the thing that says I am who I am, and the thing that validates you are who you are. And thank you for those things. And so we've got this service provider that talks to SAML. So when you enter this website, you're hitting, first off, the edge layer, which validates whether you're logged in or not. If you're not logged in, it sends you over to Stanford Pass, literally redirects you over there. Stanford Pass. Stanford Pass then asks you, are you logged in? You say, no, put in your username, password, and then it will send a payload back to the website saying this person is who they are. We take that and say, okay, they are officially who they are. And we say, we trust this user. We can now fetch data from this user. So once we get that key back from Stanford Pass, we can then use the data that's in there, which has an ID of who that user is, and then request from, we call it the Mega Profile API. So that is the API that was created by Enterprise Technology that hosts and it has all of the information, all the personal information about the end user. So IDCS, yes, thank you. That's Identity Cloud Systems with Oracle. It's not the simple assertion markup language. Anyway, it's a joke. So we call it the Mega Profile API, but that's where all the source of the information about who I am comes from. So none of this is coming from a database. This is not statically rendered. When I enter this site, it authenticates me. So now this is saying, oh, okay, I've got a cookie. It says I'm authenticated as my end user. It is now fetching, and it fetched all the information from the API and has cached it now in your browser. So all that information from all the other sections that are in here is now being cached. So when I click around, that information is all available and all in the various parts of this website where I need it to be. So it's all very snappy, very quick. So we had that little bit of a loading, which did that initial request for information and then caches it in your browser. So that's there and it's fast. Okay. So when I make a change, because this API is read and write, we'll go up to this corner here. It needs to get to the directory. And so the directory is powered by Coveo. Oop, come back. Coveo is a search engine. It's more than a search engine. It's a SaaS-based product, so they've got all sorts of things bolted on. They've got machine learning and algorithms, analytics, and you name it. So it's pretty full-featured search product. But they have an API that we pull from. But that information that was in my account that was changed needs to get into that index. How that works is that when we submit the form, we submit the data back to the API. API does a validation step and all that, making sure that it's all good. It's powered through SnapLogic, and we call this, it's Hub, that's the internal name, and Card. So that's the Oracle database, and Card is Salesforce. So Renee's here, she can probably correct me if I get anything wrong on this one, because this is where I get a little fuzzy, and this is systems and infrastructure built by ET. I didn't get a chance to invite them to this because I put this stuff together last minute, but they can dive into this. Each of these boxes is another whole bunch of boxes deeper. So this is only the first level of the dream for this. So they can get into that more. But in a nutshell, as we post things, it goes up through the API layer, through a processing pipeline, into a database, and there's a sync that happens between what is Salesforce and what is that database. When the data hits this hub, there's a trigger to push it out to Coveo, and there's two options that you can push it to. There's a batch, so if we're going to push a whole bunch of information all at once, we can then ship it in a batch, and basically what we do is we drop a very large JSON file on an S3 account and tell it to process. Or we can push things directly one at a time through an API. And so this happens fairly quickly. It's less than 5 minutes before it gets from my account to Coveo, because it's got to be processed through a few things. It's got to go through processing layers, it's got to hit Hub. This doesn't run instantaneously. It's on I think a 5-minute sync, but then it's shipped out to Coveo. Coveo has what they call processing pipelines, which then analyzes the data. So it takes all that change, puts it back in, does its stemming, does its machine learning thing, and then has it in the index. And then when I go and to the directory and I get to fetch, I'm getting fresh data directly from Coveo. So the directory site itself pulls your information on login, but all the data about each individual person is pulled from Coveo itself. So it takes a second to fetch it from Coveo. But once it's loaded, so I went to Holly Harris, come back, it's cached. So again, we have the same strategy as we ran on the My Account website. I'll get into that in a little bit. I'm gonna run short on time. But we cache it so it's super snappy as you're navigating around. And as you repeat searches, things happen really fast out of there. Did I miss any questions? Are we doing good so far? Am I losing anybody? Good. All right. One other thing to note, the assets. So when I uploaded that image, we upload them to our Storyblock, which is a CMS product, but they also have an asset management service, and they allow you to have private images. So these images are private, and they will come through a secure URL. So each time we request these images, it is a authenticated request to these images. So you can't just grab these and share them across the world. John.
Yeah, we talked about this a little bit earlier today. Can you tell me a little bit more about how the authenticated requests for static assets works?
Gotcha. So behind the scenes, there is a S3 service, and S3 has security models, whether a file is public or private, and there's in between on this one. We integrate with the image manipulation service from Storyblock to request those things. So you need, it's a sort of a 3-step way to get these images. So each of these images has a key or a URL for that asset, like where it exists in that storage. I cannot just directly navigate to that. If I try to directly navigate straight to the source image, I'll get an access denied. I need to request first from, in this case, the Storyblock has the provider in front, but I need to request a signed URL first. So I need to have a set of credentials in which then I can go and request back a signed and secure URL from the authority first, and then use that URL to go and fetch the image and present it to the browser. Andre's got a question.
Yeah, so is there a place where there's some common functionality that is provided by a framework, and where would that be located? Like, there's obviously a lot of glue code to make all this stuff work, but did any of the frameworks help you with that code?
Anything in particular? Because there's a few items here. You want to talk about the...
Well, so for authentication, for instance, often there's the framework that you then just plug in what you need to change so that you authenticate against exactly the services you need. But yeah, so did you have to start on the ground floor writing all this, or did you get to start on the 10th floor because there was a framework that helped you with some of these basic functions?
I would say probably somewhere in between. Honestly, so we do use a lot of packages that are widely available just to get us further. I'm not writing SAML validation or encryption packages by any means. Like that would be a little outside of scope. For the authentication, there isn't like a node package just for Oracle IDCS. Like you can't just install it and then put in a couple things, magically have it work, because the configuration is specific on each of the implementations that you set up. So when you're setting up your identity provider on Oracle, you'll have a bunch of things that you'll choose. So we use the package called PassportJS to then it's a framework as well for interacting with or making and receiving SAML-based authentication requests. We do have a package out there, and we have one also for web login as well that we've built, and Scotty Logan has also built one as well. That's getting a little older. I poked him on PRs on that, so if you see him, give him a poke. He needs to update things. But we use PassportJS to give us that leap so that we are connecting to those things with a unified framework as far as how the transaction happens. What it does, though, is it ends there. It handles the transaction. So you set up the way it communicates between the two systems, and then you receive back and you say, okay, yes, this communication happened. Yes, this is a valid person. Then you have to do something with that. So that's the point where you're on your own. Like, what do you do? Like, your framework helped you communicate with the foreign entity. You got to back a response saying, yep, this person's good. From there, you got to do something with it. And you can try to patch that into something else. Like there's NextAuth, and I think it's just called Auth.js now. They've changed it since, which would be something I would like to look into for next time we do this. I've built a few SSO clients in my career here, so I imagine there will be a next time. Because they provide a little bit more of a framework and a tie-in to our choices in Stack. So we chose PassportJS because it's a little bit more agnostic, and we reused a lot of that same code for other sites that are on Gatsby and a few other things. But if I was to do this again, because we're sort of consolidating a lot of the application type of stuff we do, we tend to use Next. So I would use something that gets us a little bit further on the authentication just with the Next framework, so that it will get us not only the framework to do the communication with the remote IDP, but then also give us tools to quickly implement things around like paged or route-based authentication or API authentication as well.
Okay, great, thanks.
Yeah, I tend to answer very long-windedly, so if I didn't quite get to your question, I'm also happy to try to be more succinct. Good, okay.
Well, I'll say there was like a part two, which would that I would have asked, which is like, how are the pages drawn? If you needed to make a change and you wanted it to show up on all the links, for instance. So presumably you're using some sort of design system, and then that's going to filter through to how all the pages are created. Yeah, so I'm just wondering, because I guess the microservices systems that I've seen, the teams do have to be willing to write a lot of fundamental glue code. Yeah, so you just have to be prepared for that if you go down this route, it seems. I was wondering if that was your experience with this, or if that's where I was coming from with my question.
Yeah, a lot of what has been set up has been bespoke. It was tailored from the data models themselves. It was set up to match the design of the files that we had, the design files we had. It was matched. And where we could have some improvement was also aligning with various different hardware choices for everything, because there's a lot of systems here. Like these things are running in different places as well. So we've got like Netlify is a thing, and we've got all these other services here. Oracle's a thing, SnapLogic's a thing, HubCard, like all those are in different places. So like the harmonization between all of these pieces also needs to happen. So the microservices, as far as transactions go, when you have an AWS Lambda layer, those are little tiny functions that live for 10 seconds or whatever, that spin up, spin down, they're stateless, and you can just like do tons of them. You can say run 50 of them at the same time. Your browser, HTTP2, you can, it's basically endless amount of synchronous requests. So you can just hammer at that, they go, whoop, whoop, done. Like you can just make a ton of things really, really quickly, which is awesome. And it horizontally scales out. With Lambda stuff as well, you're gonna get charged for the time that you're running. It's not always running, so they spin up, spin down, and so there's theoretically some cost savings. Although you'll be reading some articles out there how that maybe the microservices versus monolithic isn't. There's trades for sure, but you need to make sure you have a match on the other side too. So if somebody's sending 50 requests a second, the other side also needs to be able to handle 50 requests per second as well. So that's something you got to keep in mind with this. So we ended up hammering the API for a bit. And we went, oops, sorry. So when we do our initial load, we had a microservices endpoint basically for each of these sections that's in here. So we fetch information for one. So when you come in, and our initial model was to fetch the page that you're on. So wherever you land, because you get a URL, you can land directly here. And see, this is trying to load something as well. So we've got a microservices endpoint. So that refreshed. But we have a sort of consolidated endpoint as well that does the initial request for everything. So when I land on this page, on this website, I get it all in one URL. So it just does one call. And then I pre-populate the rest of the microservices with that information. So I've taken that one big request, taken all the individual responses, and put them all in the microservices so that they're all there. And I only refetch the microservices endpoint when I mutate something or I change data. So that way, everything is just immediately available and then fresh on change. So as soon as I edit something, so I don't know, we'll edit this one. I'm gonna do 1, 2, 3, fake street.
Hey Shay, sorry to interrupt. Please continue. I just want to say we've got about 5 minutes left, and Cassie also has a question.
Sure. So just quickly to finish this one. As soon as I edit a page, I then save information and then I refetch it from the API just in that microservices. So I'm just getting that little bit of information that I've changed, that gets recached, and I'm good to go. Okay, Cassie.
Yeah, thanks. This is very cool. If I have a potential application that I'd like to take this approach on, but it's much simpler, it maybe has authentication and maybe has to hit a couple of APIs to populate a form, what are there resources that you would recommend to get started on building up something like this?
It's just a simple form page with pulling some information. Yeah. I like the serverless architecture. I find it very fast, very scalable, very quick. You can get away with running mostly just the Next application framework that has a ton of things built into it. You can make all your API requests, you can make your services layer. You got to pick a host still somewhere. So that's where some of your costs and things will come into play. There's lots of different options out there. There's Vercel, Gatsby got bought up by Netlify. There's Netlify. You can go to you're not really restricted on, you can spin these up on AWS yourself if you want. Like all this stuff is sort of built on AWS. We choose these hosts because they take care of a lot for us. So if you wanted to scaffold it, it's not that much more, but it's all that effort that now you own that stack and have to maintain it. So it's nice to have that done for you. And some of them come in low cost to begin with. And then once you get big, then that's where the prices really start to escalate. So like a hobby or free tier will get you pretty good performance and pretty, like it can handle a lot of traffic. And you can get away with a pretty simple build if you're running like NextJS on things. You don't need everything else. We just had a lot of stuff.
Okay, sounds like NextJS is the first thing to look at.
Yeah, and that's just the React one that we like. There's definitely other ones. Blitz, Redwoods, it's a full stack one. So if you need a database, like none of this there's no database here outside of behind the API. I kind of missed that coming from a LAMP stack. You may miss that too, but you could add your own. There's database services you could just plug in. So that's kind of the model with all this stuff. Like that's why I was showing you all the logos. You bolt on stuff as you need it. Like you start off actually pretty small. Pick a host, pick a platform, and then from there you start adding on the things you need. The thing is, everything's such a small thing, and you can get service fatigue because there's so many services, and so you got to watch that. And then some of these hosts are bundling things in and adding, their marked up prices to it. So you got to watch that. So there's a convenience versus do-it-yourself thing there.
Shay, Kristen has a question, as well as Ray asked a question about estimated cost for the structure then.
This is the purpose of this, so I'm happy to, I can go, the slides are there, you can consume them. I've gone over most of what I want to go through, so I'd rather answer questions, so this is perfect. So we'll start with Kristen, and then I'll grab you, Ray, your comment right after. So let's go with that.
Yeah, so I was just curious, given that you have it working and running and you've been through all the pain points and everything, you touched upon, maybe you would have done something a little different with the password, architecture. Are there other things that you would be like, if I were to do it over again, I kind of wish I would have done this or used that? Or, are there any kind of, if you're going to do another application at Stanford or whatever, and you're just lessons learned and some of those things?
Sure. I think the big one for me is we started off knowing that this was going to be a big thing connected to a lot of stuff. So we started off with a microservice design. We started off with everything being very abstract and very small. And I think that hit some pain points over time. To be able to figure out where the dividing lines on things are wasn't easy. And we had lots of discussions and arguments over what belongs where. And even with that design, we've got some things that are duplicate that are just caused by them, to say. So the fact is that we didn't know at the time. So this took us almost 2 years fully to get through, and there's been lots of change. The scope went from here to here as we went along. So my approach to this would be start more monolithic, get to a certain size where the comfort level is, and then really start to pull things apart at that point. So, so to be intentionally monolithic off the start is basically what I'm saying. So the design where we are now is performant, is working great, but we had to get through a few more hurdles, I think, than we needed to get there.
All right, thanks.
Cool. Ray, you had a question. Can you please comment regarding the cost of running a system that uses serverless microservices in terms of the cost of the system you designed and used? Seems like lots of moving pieces. Yeah, so we've got a lot of different things here. There's a lot of different teams. The hosting that we have in play, we're on an enterprise contract. It's not cheap. So we got a hosting plan. I've got hobby projects that are running, fairly intense stuff at times, and I can hammer it at a relatively okay budget. But that's kind of where I'm noticing a lot of these hosts are, is they'll scale you up to a point, and then that leap is big. Like the next paycheck is a lot larger from where they leave off on your self-service price points. So does that answer your question, Ray?
Sure, yeah, I mentioned that because Amazon Prime Video did a study recently. They have a similar architecture, but then their cost is reduced from 90% to 10%.
I read that article.
When they went back to they're still using microservices, but they hosted it on their own EC2 instead of serverless. So Amazon itself acknowledged that it costs more. So I just mentioned that I should ask that question because Amazon itself, who owns AWS, says it's costly versus the traditional microservices.
Yeah, there is a return on investment on these things, especially when your microservices talk to other microservices that talk to other microservices, and like there's overhead with HTTP. These things aren't always on. Like they start up really fast, but they're put asleep when you're not using them. They're not running. So I know I'm over time. I'm sorry. So anybody can take off if you want, but I'm happy to stay and answer some more questions. But yes, there is overhead. So the microservices we have really is pretty flat. Like we don't have services talking in multiple layers. It's really just a sprawl of individual services that are small. And the idea was that they would talk to another small endpoint on the other side to keep the amount of data that needs to move discrete. But also because these are only 2 of about a dozen websites that are using this data that we use, and then there's going to be other places that use this data. So we had discrete endpoints that we can then individually control access to for other things as well. And so they could connect to and just receive the data that they require. And so they wouldn't get other information that they shouldn't, for one. And also we could be more controlling or have more stewardship over the data that's there, because there's a privacy layer that's involved here as well. We want to make sure that this information isn't being posted publicly when the user says, this is private. So our splitting wasn't as much for the fact that we have to have lots of things talking to lots of things. It was more a separation of concern type of approach to that. Maintenance like this with so many components, pros and cons. Maintenance wise, not too bad, honestly. Governance wise, it's a bit more challenging. Because we share this information, because there's multiple individuals that have influence or say, when things change, becomes more of a governance problem than a maintenance problem. All the stuff that we get in our microservices layer that comes from a spec. So we work with Enterprise Technology. They build, in MuleSoft, they call it RAML. It's relationship, I can't remember what it was, but it's similar to OpenAI, or not OpenAI, Swagger, who's now, who they are, but it's the Open API spec, similar, but it's a YAML based one. So basically it's the design of the other endpoints and all the data types and that stuff. So we can consume that file and update our end of it basically from that spec. So maintenance wise, we basically import and generate all of our typing. And then our services layer is how we interact with the website. And so that doesn't change unless we want it to.
One thing that strikes me is there are so many moving components, you do actually need a fairly long runway so that you can train all the people on all the different tools and libraries. A few years back, I was on a project where time to market was important. And even though we were looking at all the possibilities, decoupled, whatever, we actually went straight monolithic because we're like, listen, we need people who know the whole system from A to Z, and they're going to, run like hell for the next 10 months. And we can't afford to stop and teach them everything in this sort of kind of multi-service world. But you can do it later. If you want to improve the site and you have the budget, after you've done monolithic, you can at least shard some of the functionality off.
I've got to give massive kudos to our development team. We had turnover during this project as well. We had individuals that were leading things up leave midstream. We had people come on that didn't know stuff that had to get up to speed quickly. I was a Drupal developer 2 years ago. And I don't say that negatively, like a lot of this stuff is new to me. So our team had to learn a ton to make this work. We spent a ton of time learning, a ton of time listening, a ton of time trying things out. Like I wasn't a Coveo expert last year. I didn't even know what Coveo was last year. So they've got training, and part of the timeline of this was time to learn. And so when you're getting into things like this, budgeting the time to have those explores and the training for your team, and it doesn't have to be classroom training, it just has to be butt and seats hacking at stuff, having them progress, and done in a way that's safe as well. So having proper workflows for developers, having staging and dev environments, having review discussions, lots of communication about things. Our developers talk a lot. We talk about code a ton. We read documentation all the time, and we don't always, and that's okay. But I'm very much into code ownership. Like the individuals writing the code, that's theirs, and that's their section. It needs to work with other stuff. Don't get me wrong, but they're allowed to bring their skill to it, their knowledge, wherever they are at that time. And that's theirs. And when things need to change in that, that's who I go to. That's the expert in that area. So they take ownership on it. They also become the expert on it. Turnover, fine. I'd rather, it's not nice. We have to then have somebody else step in, figure that out, take it over. And it's not ever anybody's favorite work is to take somebody else's work and go with it. However, I worry much more about making sure the individuals I have are interested in getting better versus them leaving. I'd rather spend more time invested on them learning, growing, than worrying about them going away and trying to protect against that. So I give huge kudos to individuals who've come onto this and have taken on ownership and have learned a whole bunch of stuff and got into the scary and just did it. So we spent a ton of time, and refactoring is a big thing too. Done a lot of that. So that's a good call out.
Thank you.
Cool. All right. Well, I thank you all for the awesome questions that's in here. We were way over time, so I'm going to end the session there. But there's some notes on the slides if you want. I'm on Slack. Most of you are here. You can send an email if you want to get a hold of me. I'll be in another session later today as well. So thank you very much for listening and joining us.
Thank you.
Thanks for the presentation, Jay.
All right.
Thanks, Jay.